Welcome to Voltage Divider Bias Thevenin Review. Alright, so here's our Thevenin equivalent circuit. Got VThev, and RThev. We're going to put our load back in. So for universal bias, the load is from here to here. We're going to treat this right here as the load. So we're going to pull that load, and we're going to solve for RThev, we're going to pull that load, and we're going to look back, and we're going to see what voltage the load sees, or sorry, what impedance the load sees. And in this case, R Thevenin is equal to R1 in parallel with R2. Now V Thevenin is going to be equal to VR2 with the load pulled. So if the load is pulled, our current through this branch is through R1 and R2 only. So we get current is equal to VCC divided by R1 plus R2. So if I've got the current there through that branch, now if I want the voltage of VR2, I'm going to multiply that current by R2. That gives me my V Thevenin. Now, if I've got V Thevenin and I've got R Thevenin, I've got RE right here. If I write a loop equation, I can now, because I'm interested in solving for IB. So I'm going to write a loop equation here. That gives me minus VThev plus VRThev plus VBE plus VRE has to equal 0. So now I can rewrite this. I've got VRThev plus VRE equals VThev minus VBE. VThev is going to be equal to IB times RThev plus IE times RE. That's going to be equal to VThev minus VBE. Now we can get IE in terms of IB. IB times beta plus 1 times RE equals VThev minus VBE. Factor out the IBs. Factor out the IBs. Minus VBE. Now I'm going to change colors just so we can see. Now we're going to rewrite this so we can solve for IB. IB is equal to VThev minus VBE divided by RThev plus beta plus 1 times RE. And now I've got IB. So the next thing you want to check when you're doing Thevenin analysis, because Thevenin is based on a theorem, you want to make sure that your IB, or rather your IR2, here's your IR2 right here, IR2 is at least 10 times bigger than your IB. If you make sure that your IR2 is 10 times bigger than IB, you're good to go. Now you can go ahead and solve for all your voltages and your DC load line. If your IR2 is less than 10 times your IB, you should probably go back and do Kirchhoff analysis on this circuit by doing loop equations and doing mesh simultaneous linear equations, just like we did in the previous homework.